everyone, and welcome. Have you ever looked at a game of chance and just wondered how it really works? Well, today we're going to pull back the curtain on probability. We're going to crack the code using two super common examples, a simple pair of dice and, you guessed it, a full piggy bank. I mean, think about it for a second. We hear it all the time, right? There's a 30% chance of rain, or you're wondering what the odds are of winning that board game. Probability is literally all around us. It's basically the science of making educated guesses with a little bit of math to prove you're right. So really, what are the odds? Okay, so let's get right into it. We've got two fun little challenges lined up. First, we're going to figure out the real probability of rolling certain numbers with two dice. And after that, we're going to shake a piggy bank and see what the chances are of pulling out a specific coin. And trust me, it's way more straightforward than you might think. But hang on. Before we can solve anything, we need to be on the same page. We've got to learn the language of chance. So let's quickly cover the one single fundamental rule you need to know to solve basically any problem like this. So what even is probability? You know, at its core, it's just a number between 0 and 1. That's it. If the probability is 0, it's never, ever going to happen. It's impossible. If it's 1, it's a sure thing. It's absolutely certain. And pretty much everything else in life, well, it falls somewhere in between. And this right here, this is the whole shebang. This is the golden rule. Every single thing we do today comes back to this one simple idea. You just have to remember, it's what you want to happen divided by all the things that could possibly happen. That's it. All right, let's get our hands dirty and put that rule to the test. First up, the dice roll. Now, the most important first step is always to figure out the bottom part of that fraction, the total possible outcomes. To do that, we need a map of every single thing that could happen. So, I've got a question for you. Imagine you have two dice. Maybe one's blue and one's gray. You roll them. How many different, unique combinations could you possibly get? Just take a moment. Think about it. Boom! Here is the answer, laid out perfectly. All 36 possible outcomes. You can see how rolling a 1 on the blue and a 2 on the gray is a totally different outcome than a 2 on the blue and a 1 on the gray. This grid is our map. It's our complete universe of possibilities. So our total possible outcomes number is 36. Okay, now that we have our trusty map of all 36 outcomes, we can finally start answering some real questions. We're just going to apply that golden rule we talked about. So here's our first mission. What are the chances that when you roll the dice, the two numbers facing up add up to exactly 8? Remember our formula, we need to find the favorable outcomes. Let's go back to our map and just do a little treasure hunt. Okay, where are the 8s? Let's see. A 2 and a 6? Yep, that's 8. A 3 and 5? That works. 4 and 4, of course. 5 and 3. And finally, a 6 and a 2. And that's all of them. We have exactly 5 combinations that add up to 8. Now for the easy part. We just plug our numbers into the formula. The number of outcomes we want, our favorable ones, is 5. The total number of outcomes we know is 36. So the probability is simply 5 out of 36. See? Not so bad. Okay, let's try another one. What's the probability that the sum of the dice is 13? Go on, take a look at our map. Scan every single one of those 36 squares. Are there any two numbers that add up to 13? No way. The absolute highest you can get is a 6 and a 6, which is 12. So rolling a 13 is impossible. The number of favorable outcomes is 0, which means the probability is a big fat 0. All right, last dice question, I promise. What is the probability that the sum is less than or equal to 12? Well, think about it. We just said the highest possible sum is 12, right? So that means that every single one of our 36 outcomes works. They all result in a sum that is 12 or less. So our favorable outcomes are 36, and our total outcomes are 36. And what's 36 divided by 36? It's 1, a certainty. Awesome, we've pretty much mastered the dice problem. So now let's switch gears and tackle that piggy bank. Now this might feel like a totally different puzzle, but you're about to see how the exact same thinking, that same golden rule, is all we're gonna need. So here's the loot inside our piggy bank. We've got a whole bunch of different coins. And just like we did with the dice, our very first job is to figure out the total possible outcomes. In this case, that's just, well, the total number of coins in the bank. So let's do some quick addition. We've got 100 plus 50 plus 20 plus 10, which gives us a grand total of 180 coins.
Perfect. That's our bottom number, our denominator for this whole piggy bank problem.
Okay, first question. If you close your eyes, shake the bank, and one coin falls out, what is the probability that it's a 50p coin? Let's use our golden rule. The number of favorable outcomes, which is the number of 50p coins, is 100. The total number of coins is 180. So our probability is 100 over 180. And if we simplify that fraction, it comes down to 5 knights.
All right, one final challenge. And this one has a little twist. What is the probability that the coin you pull out is not a 5 rupee coin?
Okay, there are a few ways to think about this, but let's do it the most direct way. We want to find the number of coins that are favorable, which in this case is any coin that isn't a 5 rupee coin. So we take our total of 180 coins, we subtract those 10 5 rupee coins, and that leaves us with 170. So our probability is 170 out of 180, which simplifies down to 17/18. So there we have it. We've rolled dice, we've shaken out a piggy bank, and we used the exact same logic to solve both. Let's just boil this all down into one simple, powerful takeaway that you can, carry in your pocket. Honestly, it all comes down to this. No matter how complicated a probability problem might seem, it's always just these 3 steps. Step 1, figure out everything that could possibly happen. Step 2, count up only the things you're actually hoping for. And step 3, just divide that second number by the first. That's it. That's the secret sauce. So now you have the toolkit, you know the method. I'll leave you with this thought. From shuffling a deck of cards to drawing a name out of a hat, what everyday game of chance can you solve now? Think about it. Thanks so much for tuning in.